So we've seen that a vector a plane with containing the point x naught, y naught, z naught, perpendicular to the vector ai plus bj plus ck, has the property that a point x, y, z is in the plane if and only if the vector from the known point to that point x, y, z is perpendicular to the normal vector, and that gives us the equation of a plane. Now let's do a specific example. Let's find the equation of a plane through 2, 5, negative 3 perpendicular to this normal vector 3i minus 7j plus 6k. Now we could identify a, x naught, y naught, z naught and use a formula, but we're actually probably better off if we sketch ourselves a little representation of the situation. So let's say that we have the point 2, 5, negative 3, normal vector, and we're not going to attempt to draw this vector on any set of coordinate axes, but this vector will represent our normal vector, which is 3i minus 7j plus 6k, and xyz is going to represent a point that we want to determine whether this point is on the plane or not. And we find that the point is on the plane if and only if this vector is perpendicular to this vector. This vector is going to be x minus 2i plus y minus 5j plus quantity z minus negative 3, which would make it z plus 3 times k. If this vector is perpendicular to this, then xyz lies on the plane, and if xyz lies on the plane, then this vector must be perpendicular to this one. So by taking the dot product of these two vectors, we're going to say that 3i minus 7j plus 6k dotted with our vector x minus 2i plus y minus 5j plus z plus 3k. These two vectors are perpendicular if this is equal to 0, giving us the equation of the plane. Multiplying our I, j, and k components, adding them up and setting them equal to 0, we get 3 times x minus 2 minus 7 times y minus 5 plus 6 times z plus 3 equals 0. And this is going to be the equation of our plane. So our plane is expressed by the equation, by this equation. If we multiply through using the distributive law, we're going to get 3x minus 7y plus 6z. And then we're going to get minus 6 plus 35 plus 18. Now 35 and 18 is 53, minus 6 is 47. So I believe that plane is going to be 3x minus 7y plus 6z plus 47 equals 0. We ask, what would be a point on this plane? Well, we can find a point and actually right now we're going to verify that 2, 5, negative 3 is on the plane. And to do that, we simply plug 2 in for x, 5 for y, and negative 3 for z. We end up with 3 times 2 minus 7 times 5 plus 6 times negative 3 plus 47 equals 0. Now this equation should hold since this point we know to be on the plane. So let's see, we get 6 minus 35 minus 18 plus 47 equals 0. If my arithmetic is correct, this side adds up to 0. We get 0 equals 0, and that verifies that the point is on the plane.